Okay, so anybody need the animated session? Okay, nobody is interested. Okay, so for now we have discussed about square, pyramids, and cone. So before going to continue my session, I'm going to explain the few basic basic things and basic nomenclatures about the solids. Okay, so we have already discussed about the nomenclatures like slant edges and longer edges, and also triangular face, rectangular face, apex, generator. Okay, and similar to that, some kind of solids will be called with the name of different names called truncated solid and frustum. Okay, so what is meant by truncated solid and what is meant by frustum? So it is a off solid, so we can simply call it as off solid. For example, it is based upon the cutting planes. So this truncated solid and forums, frustums will not be available in projection of solids, because in projection of solids we are not going to discuss about the sectional planes. Okay, so it is based upon the section planes. So normally this particular triangle is called as cone. Okay, we can generate these kind of cones with the help of a revolution method. Okay, so with the help of revolution method, we can able to generate cones, cylinders, and spheres. For example, if you are creating a 2D structure like this, okay, so you are creating a 2D structure like this triangle, then you are going to rotate this 2D structure with the help of a center axis. So this one is a center axis. If you are rotating this 2D structure in a revolution method, you can able to generate a cone. Okay, similar to that, if you are rotating a rectangle like this, you can able to generate cylinders. Okay, similar to that, if you are rotating a off circle, okay, you can able to generate a sphere. So what is meant by sphere? For example, a normal cricket ball or else volleyball ball and football. So these kind of balls in a sphere structure. So we can able to generate these kind of three solids with the help of a revolution method. Okay, similar to that, if you are creating a section plane parallel to the reference line. Okay, so now this one as a, please consider this one as a pyramid. So it is not a cone, it is a square pyramid. Please consider this front view as a square pyramid. So I'm going to cut this square pyramid with the help of a section parallel to the reference. Okay, so this section plane is parallel to this reference line. So if it is parallel, I'm going to remove the top portion. Then this particular structure will be called as frustum. So we can able to create or generate frustum in cones or all in. So frustum can't be generated in so what is called prisms, or else we can't able to generate frustum in cylinders. So it can be generated in call it as a cone, and also we can able to generate frustum in pyramids. Okay. Then the next one, that is called truncated solid. So truncated solid can be generated in any kind of solids like cylinders, prisms, pyramid, okay, and also cone. So we can able to generate truncated solid. So what is meant by truncated solid? If we are creating a inclined section plane like this, and also if you are removing a top portion, then the remaining portion will be called as truncated solid. Okay, if you're creating a parallel section plane, then we can call this remaining portion as a frustum. This is only applicable for cone and pyramid. It is not applicable for prism, and also it is not applicable for cylinders. Then we can we can call it as frustum. So FRUSTEM. So truncated solid is applicable for all kind of solids, but the condition is that the section plane should have a inclined angle. Okay, so this is the basic instruction of nomenclature. Up to this, we have discussed in our last class. Discussed about cone, and in this cone itself. So this is the basic concept. The concept set. So how to draw a sectional top view and how to draw a true shape. So this concept is applicable for all kind of solids. The concept தான் சொல்றேன். அதாவது drawing whatever concept it is applicable, but creating the sectional plane is different for each and every problem. So in this problem, we have discussed about the cutting plane is having an angle of 45 degree, okay? And it is cutting at the axis point 35 mm above the base. So based on this, we have created a point that is 35 mm above the reference line, and also we have created the inclined section plane with an angle of 45 degree. Similar to this, for example, the condition will be like a sectional plane is parallel to the generator and it is 10 mm far away from the generator. For then you have to create your front view like this. Okay, then what is called generator? Either this line is a generator or else this line is a generator. So we have to create the sectional plane parallel to any one of the generator. Okay, and also the condition is the generator is 10 mm far away from the 10 mm far away. So it should be parallel, and also with that it should have a 10 mm distance. Okay, so it is not a horizontal distance, it is a parallel distance. So this distance should be 10 mm. So this is one kind of creating the sectional plane. In some problems they will provide about this axis. So they will provide the distance of the axis. So this particular point distance. So it is bisecting the axis, and also the section plane is parallel to the generator. So you have to pick a point exactly at the center of your cone. In some problems they will provide it is having a distance of 40 mm from the apex. So you have to create a 40 mm to this side. In some problems they will provide a distance of it is having a 30 mm from the reference line. So you have to create at a point with a distance of 30 mm. So this is what the condition. This is the difference of the condition. இதை தவிர வேற எந்த கண்டிஷனுமே கிடையாது. Okay, you know how to create a front view and top view initially, and different condition for third unit is that it is only applicable only on section plane. Okay, section plane பொறுத்து தான் நம்ம conditions மாறும். In some problems they will provide about section planes that may be applicable on top view itself. So here we are creating the section plane on front view because the section plane is inclined at 45 degree to VP. Similar to that, you will be having another one more condition that is inclined on 45 degree to VP. Okay, if you receive a condition like that, then you have to create your section plane in the top view. So you have to create your top view like this. So please consider this as a circle. Okay, then you will be receiving a condition like 45 degree to VP and 8 mm far away from the axis. So this one is the axis point. So it is the center point. So you have to create a circle like this with the diameter, with the radius of 8 mm. Because our condition is that 45 degree to VP, then 8 away, far away from the axis. So we have to create a circle with a radius of 8 mm. So please consider this with the radius of 8 mm. So you should not create diameter of 8 mm. ஏன்னா இந்த ஆக்சிஸ் பாயிண்ட்லேருந்து 8 mm டிஸ்டன்ஸ் இருக்கணும் எந்த சைடு மெஷர் பண்ணாலும். Then you can generate section plane with an angle of 45 degree like this. So it should touches the inner circle. It should touches the surface of your inner circle. So this angle should be 45 degree. So இந்த மாதிரியும் problems வரும். Okay, so I'm going to discuss about one of the problem related with incline to VP with the help of PPT. So this with the help of video. So I'm going to play this video. So it is a section of cone. Okay, a cone. Please, I'm going to read out the problem first. A cone, base 50 mm diameter and axis 60 mm long, rest with its base on HP. So base is on HP, so your top view will look like a circle. Okay, so it is cut by a section plane. It is cut by a section plane perpendicular to HP. So before that, I think I have not noted the ordinance. Okay, no problem. So it is cut by a section plane. So we are having the word called section plane. Okay, perpendicular to HP and inclined at 60 degree to VP. So I think you are not can't able to see my cursor. Please just a minute. Okay, no problem. I'm going to use a different method. So here, please, you'll be having a circle like this. So this is my cursor. So please don't follow this cursor. Okay, so it is cut by a section plane perpendicular to HP, inclined at 60 degree to VP. Okay, so we are having an inclined angle with 60 degree to VP. So we have to create a section plane in the top view and at a distance of 10 away from its axis. So previously we have discussed about 8 mm. So here the distance is 10 away from the axis. So you have to create your inner circle that is 10 mm, that is having a 10 mm of radius. So you can create your sectional front view and true shape. So normally you can create a circle with 8 divisions because our base is on HP. So you have to draw the circle in the top view position. Then you can project your each and every points towards your front view with and the axis height is 60 mm. Okay, then you can connect all the points with the apex point. So this one is the apex point. So you can name this apex point as O dash. Okay, then our condition is that then we have to follow the cutting plane condition. Okay, so up to this it is normal. It is based upon our second unit. Okay, so you have to create this cutting plane that is perpendicular to HP and inclined at 60 degree to VP. So you have to create your cutting plane in the top view and at a distance of 10 mm from its axis. Okay, so you have to create a circle, imaginary circle. So it is an imaginary circle. Please don't highlight the circle. Okay, so you can create another one more circle at this place. That circle should have a radius of 10 mm. Then the diameter is 20 mm. Okay, if the radius is 10 mm, then the diameter is 20 mm. So you can create a circle with a radius of 10 mm. Okay, so before that you can mark all the notations in the front view. Okay. Then after doing that, please create the circle. So now the circle is created with a value of 10 mm radius. Then you have to create a rough line with an angle of 60 degree, because our condition is that section is an angle of 60 degree to VP. So this particular line is having an angle of 60 degree. Okay, so you highlight only the lines that is available in between the larger circle, because that is what our section line. So please remember one thing, you have to remove the minor portion of your solid. So the major portion, you can left the major portion as it is. So you have to remove the minor portion. So this is what our minor portion. This one is our larger portion. So you can highlight the larger portion. That means you have to highlight the outermost circle, particularly on the larger portion. So the smaller portion has been removed. Okay, so then you can project your cutting points towards our front view. So here we are having a multiple cutting points. That means particularly we are having 5 cutting points. Okay, so first cutting point is available in between A to H. So this outermost circle, that means it is cutting the base. So you have to project this cutting point up to only the base. So the next cutting point, actually it is at in between O to A. So you have to project this second cutting point up to a line called O to A. Okay, then the third cutting point. So please look at the third cutting point. So it is available in B to O. Okay, so you have to project this third cutting point up to the line called B to O. So up to this. So B to O line is here. So you have to project up to this. So this is our third cutting point. Then the fourth cutting point is exactly available on the vertical line. So it should not be projected directly. So what is our condition? So we have to reverse the condition. Okay, so initially we have projected the vertical line from our front view to top view. So here we have to project from the top view to front view. Okay, so what's our condition? So now on the PPT la. So that is what this is what our condition, right? So we have projected this particular center vertical cutting point up to the generator. Then we have projected up to the horizontal line. Then what we have did, we have created an arc up to this point. Then we have generated the third vertical point. So here we have to reverse the procedure. That means initially we have to create an arc, then we have to create the vertical line, then we have to create the horizontal line. So we will be getting the vertical cutting section. Okay. So please reverse the procedure for this. So you can take the distance between O to 4. Okay, so you can take the distance between O to 4. Then you have to create an arc first. That means the center point of your compass should be placed exactly at O. So you can create an arc like this. Okay, then what is our procedure? You have to create the vertical line up to generator. Okay, so the generator is O dash to E dash. So we have projected up to O dash to E dash. Then what is our next procedure? You have to create a horizontal line from this point. So if we are creating a horizontal line up to axis, you will be getting the cutting point. So this one is our cutting point. So we can name it as 4 dash. Okay, so we can name the cutting point as 4 dash. Then the final cutting point, that is fifth cutting point, is available exactly at the base. So that means C to D. So So you can project this fifth cutting point up to the base of C to D. So here it is C and here it is D. Okay. So you can project up to C to D. So you'll be getting the fifth cutting point. Okay. So now you can connect all the cutting points because we got 1 dash and also 2 dash, 3 dash, 4 dash and 5 dash. So you can connect these 5 cutting points with an arc. Okay. So you have to create only the arc because we are discussing about cone and also while discussing about cone and cylinder, you have to create only arc because cone is having a circular base and cylinder is having a circular base. Okay, so if a circle is placed, then you have to create only an arc for a cutting section. So particularly the arc should be drawn only with free hand. So you should not use compass or else you should not use procer. So you have to create arc that should be created only with your free hand, and also with that, please remember a very important point. You should not create a sharp corner. So it should be a perfect smooth curve. Okay, then you can remove the front portion. So you can highlight the remaining major portion. So only this minor portion has been removed. So only the front portion has been removed. So you don't have to highlight the front portion. So you can highlight the remaining major portion with a dot line. Okay. So this one has been highlighted because it is a cutting section. That means you have to section these cutting section with a hatching line. Then you can highlight the remaining portion. So you can highlight this line, and also you can highlight this line. Okay, then you have to create the section lines. Okay, so section line should be created only with 2H pencil. Okay, so you have to use only 2H pencil for creating the section lines or else hatching lines. So the procedure is you have to create these hatching lines with a distance of 2 mm and then with an angle of 45 degree. So please remember this. So far now we have created the sectional front view. Because the cutting plane is in top view, so we can able to create the sectional front view. In our previous problem, the cutting plane is in front view, so we have created the sectional top view. So here we have created the sectional front view. Then what is our next condition? We have to create the true shape. So what is our procedure? You can create an imaginary reference line that is parallel to the cutting plane or else section plane. So this is what our cutting plane, right? So you can create a parallel line towards this section plane. So I'm not having a space on the bottom. So my drawing sheet, the bottom surface is fully utilized. So I can create a cutting plane, that means a parallel reference line on right side of this diagram. So it is your own choice. Either you can choose your left side, that means at this place, or else you can choose the right side diagram, right side place. So I'm getting a space on my right side. So I'm going to create a imaginary reference line that is parallel to this section line. So it should be parallel to this section line. So you can name it as X1, Y1. So we have already named it as X and Y. That is our reference line. So now you are creating the imaginary reference line. Okay, it should be parallel to this section line. That means this particular line is having an angle of 60 degree. Okay, so what's our procedure? You have to project all your cutting points towards this reference line with an angle, with a line of having 90 degree. So that line should have a 90 degree angle towards this section plane. So you can project up to the reference line. Then you can measure the distance from your front view. So 1 dash is available exactly on the reference line. So you can name the imaginary reference line as 1 dash. Then the 2 dash is far away from the reference line. So you have to measure this vertical distance with your compass. So measure this vertical distance. Then you can place your compass exactly at this point. Then you can create arc like this. Then you can mark it as 2 dash. sorry, 2, 1. Then you can measure the distance of 3, 1. Then you can mark it as 3, 1. Then you can measure the distance of 4, 1. So 4, 1 is far away from reference line. You can mark it as 4, 1. Then the 5, 1, 5 dash is exactly available on the reference line. So in the point project you can mark that point as 5, 1 because 5 dash is available on the reference line. So you can mark this point as 5, 1. So what is our procedure? You have to join these 5 points with the arc, freehand arc. Okay, so you can please don't forget this. The base should be also highlighted. So this particular line also should be highlighted. Then this particular arc should be highlighted. Then you can create your section lines and you can name this diagram as true shape of section. Okay, so this is our final diagram. So இதுக்கு முன்னாடி பார்த்ததும் கோன் தான், இப்போவும் கோன் தான். ஓகே, கண்ணா நான் உங்களுக்கு வந்து ரெகுலராகவே வந்து கிளாஸ் ரூமில் ரெக்கார்ட் பண்ணுற வீடியோவை மீட்டில் ரெக்கார்ட் பண்ணுற வீடியோவை கிளாஸ் ரூமில் அப்லோட் பண்ணிட்டு இருக்கேன். இஃப் யூ நீட் எனி ஃபர்தர் மோர் வீடியோ ஹெல்ப், யூ கேன் ரெஃபர் யூடியூப் சேனல். Okay, so please make a note of that particular YouTube channel. So the name is Rajagopal Thangavel Forum. Okay, so I will show you that YouTube channel. I think I'm having a bookmark. So please look at this Rajagopal Thangavel Forum. Okay, so you can directly go to that YouTube channel with the name of Rajagopal Thangavel Forum. Okay, so you're having multiple videos, so please don't have a look at this. Please go to the playlist. Okay, so if you are looking at the playlist, you can able to see a heading of projection of solids. Okay, so here I'm having a playlist of projection of solids. So in this, there is a 20 videos has been uploaded. It is based on your second unit. Okay, so look at this section of solids. It is our third unit. So here we are having a 13 videos. Okay, so it is based on your syllabus. This particular playlist is based on your syllabus. So you can have a look at this. So the name is Rajagopal Thangavel Forum. Okay, so you can use this YouTube channel for your doubt clarification. Okay, so any doubts? Do you have any doubts? Okay, Kana. So the next video is based on cone itself. Here the condition, so we have discussed about this, and next is also based on cone. Okay, a cone base 50 mm diameter, axis 65 mm long, rest with base on HP. So if the base is on HP, then we can draw the top view with a circle. Then it is cut by a section plane such that true shape produced. Okay, so here the section plane condition is totally different. Okay, so what is the condition? We are not having the angle, section plane angle, and also we are not having the distance of the section plane. So instead of that, a section plane such that true shape produced is a parabola. So if we are creating a circle, you will be getting a true shape with different structure. Here the structure is explained. So the structure, true shape structure is that parabola of base 35 mm. Okay, so the base of your parabola is 35 mm. That means we have discussed about this problem. So please look at the true shape in our final diagram. So this is what our true shape, right? So this structure is look like a parabola for our current problem. This particular structure will look like a parabola for our particular problem, and the condition is that this particular base is having a distance of 35 mm. That is what mentioned in our current problem. This particular base is having a distance of 35. So in our current problem, we have not discussed about this particular distance, and also there is no mentioning about this angle. Only condition is that the true shape will look like a parabola and the bottom base is having a distance of 35 mm. அப்ப என்னப்பா meaning? Because we are projecting only this particular structure towards this. That means if base is having a 35 mm distance, then this particular line is also having a 35 mm distance. Okay, so that is what our assumption. So the cutting section is having a distance of 35 mm. So here you have to create the sectional top view and the true shape of the section. So please look at this word sectional top view. It is not sectional front view. It is a sectional top view. So the cutting plane will be available in front view. So then only you can able to create the sectional top view. Okay, so please follow the same procedure that we have used. So I'm going to skip that regular diagrams. So you can create your circle with a division, then you can create your front view. And what is your condition? The true shape should look like a parabola and the base should have a 35 mm distance. So initially you can create a base first, okay, with a distance of 35 mm. Okay, so please use your drafter scale for this. Okay, you can use your L-type drafter scale. So the drafter scale, the longer scale should be placed exactly at this particular horizontal line. So the longer scale should have a parallelity towards this horizontal line. Okay, then you can generate a vertical line with a distance of 35 mm. ஒரு ஸ்கேல் வந்து இந்த லைனுக்கு பேரலா இருந்துச்சுன்னா இன்னொரு வெர்டிக்கல் ஸ்கேல் வந்து பாத்தீங்கன்னா அதுக்கு 90 டிகிரி இருக்கும். ஸோ அந்த வெர்டிக்கல் ஸ்கேலை அப்படியே நீங்க ட்ராக் பண்ணிக்கிட்டே வந்தீங்கன்னா at any point it will have a 35 mm distance and also it will touch the two edges will touch the circle. Okay, so you can create a line with a distance of 35 mm and the starting point and the ending point should be on the circle. So it can be applicable only with the help of your drafter scale. அதாவது இந்த 35 mm line verticalaவும் இருக்கணும், at the same time the starting point அதுவும் circular touch ஆயிருக்கணும், ending pointடும் circular touch ஆயிருக்கணும், and also the distance should be 35 mm. Okay, so you can project this 35 mm line up to your front view. Okay, up to your front view. Okay, it is not our cutting plane. So the cutting, I already told you that the cutting plane will be available only in the front view. So you have to project this 35 mm base up to your front view. Okay, so if you are projecting that, you'll be getting a point with the name of 1 dash. Okay, so you'll be getting a point exactly with the name of 1 dash. So here we got the point. So this one is our point. Then the condition is that we can able to get the, if you want to get your true shape with a parabola, then your cutting plane should be parallel to the generator. Okay, then the cutting plane should be parallel to the generator. உனக்கு true shape parabola வரணும் அப்படின்னா compulsorily for a cone, the cutting plane should be parallel to the generator. So we have already discussed about the parallelity of the generator, but in that condition we have discussed about the distance of the parallelity. So here we are not having the distance of parallelity. So we have created a vertical line on our top view with a distance of 35 mm, and also with that the starting point and the ending point should touches the circle. So now we have created this, then we have projected this 35 mm vertical line towards our front view. So if we are projecting this, you will be getting a point. That point can be named with a notation of 1 dash. Okay, so if you got 1 point, you can able to create a section line. So this section line should have parallelity. That means it should be parallel to the generator. So this is what our generator. So this particular section line should be parallel to the generator. So what is our condition? Next condition, we have to remove the smaller portion. So we have removed this top portion, then this bottom portion can be taken as a solid. So what is the name of this solid? So this one is a truncated solid because the section plane is having an angle. If we have created a section plane with parallel to this reference line, and also if it is a cone or pyramid, then we can call it as frustum. So here the section line is having an inclined angle. So we can call this sectional solid as a truncated solid. Okay, so you can highlight the bottom surfaces. Okay, you can highlight this particular line, and also you can highlight this particular line, and also the section line should be highlighted. Only this is our structure. This top structure has been removed. Okay, so you can project all the cutting points to our top view, and also you can create a true shape after our basic condition. We can follow the basic procedure for creating the rest of our diagrams. So this particular circle also should be highlighted, and this particular circle arc should not be highlighted because we have removed this. Then what is our condition? You can project all our cutting points. So இந்த இடத்துல எத்தனை cutting points இருக்கு? Roll number 56. Roll number 56.
Sir.
Okay, ma. So please look at our front view, particularly on this sectional plane. So இங்க எத்தனை cutting points இருக்கு? So one is already highlighted. இங்க வந்து பார்த்தீங்கன்னா ஒன் டேஷ்னு கொடுத்துட்டோம். ஸோ அது இல்லாமல் எத்தனை cutting points இருக்கு?
3 sir.
3 எங்கெங்க சொல்ல முடியுமா?
Sir,
on
axis sir.
On axis, okay, at this place, right? Then
Sir, O dash E dash line.
O dash E dash, another one more cutting point, okay.
In between the two lines, 1 point sir.
Okay, so இது மூணுமே உங்களுக்கு cutting point, correct தான். But please look at the notations. Actually, this axis is having a notation of O dash and C dash of G dash. Okay, அப்படிதான் meaning. So O dash to C dash is a line, and O dash to G dash is another line. That means here we are having 2 cutting points. உனக்கு பார்க்கறதுக்கு ஒண்ணா தான் தெரியும், but here we are having 2 cutting points. Similar to that, this particular point is having a notation of D dash of F dash. So here also it is a 2 line. So O dash to D dash is having one more cutting point, and O dash to F dash is having another one more cutting point. அப்போ இந்த இடத்துல ரெண்டு கட்டிங் பாயிண்ட் இருக்கு, இங்க ரெண்டு கட்டிங் பாயிண்ட், இங்க ஒன்று தான். பிகாஸ் த அவுட்டர் மோஸ்ட் லைன் இஸ் ஹேவிங் நோட்டேஷன் ஆஃப் O dash to E dash. அப்போ அது ஒன்று தான். ஸோ இங்கே ஒன்று, இங்கே ரெண்டு, இங்கே ரெண்டு. அப்போ இங்கேயே எனக்கு என்ன ஆச்சு, 5 கட்டிங் பாயிண்ட் ஆச்சு. அப்புறம் இந்த பாயிண்ட். ஸோ இந்த பாயிண்ட் நம்ம ஆல்ரெடி இங்கே ஜென்ரேட் பண்ணிட்டோம், கரெக்டா? ஸோ இது ஒரு கட்டிங் பாயிண்ட், அப்புறம் இது ஒரு கட்டிங் பாயிண்ட். அப்போ இந்த இடத்துல ரெண்டு கட்டிங் பாயிண்ட் இருக்கு. ஸோ டோட்டலி 7 cutting points. Okay, so please look at the rest of our video. We're having 4 more minutes. Okay, so you have to project all your cutting points towards top view, but this axis should be projected with a different procedure. So what is our procedure? You have to create a horizontal line from this towards the generator, then you have to create a vertical line, then you can create a arc, bottom core arc, top core arc, ரெண்டு arc வரும். Okay, already we have noted this as 1 dash and 2 dash. So this one is 1 dash, okay, and this one is, so இந்த இடத்துல ஒரு 2 dash இருக்கு. சாரி பாய், 8 கட்டிங் பாயிண்ட் இருக்கு. இந்த இடத்துல ஒரு டச்சிங் வருது. ஸோ இந்த இடத்துலயும் வந்து பார்த்தீங்கன்னா ஒரு கட்டிங் பாயிண்ட் இருக்கு. ஸோ தட் இஸ் வாட் 2, that is marked with as 2. So this axis has been projected with the horizontal line, then with the vertical line. Okay, so up to this horizontal line, then you can create an arc from O. That means you have to create 2 arcs with this distance. So if you're creating an arc towards bottom, you will be getting a cutting point, and if you're creating an arc towards top, and you'll be getting another one more cutting point. So one will be on O2C and one will be on O2G. The next one is this one. So this one should be projected up to O2D and O2F. So you'll be having 2 cutting points. You can directly project this cutting point. So if you're projecting that, you'll be getting 2 cutting points. One is on O2F and another one is on O2D. So O2D, here I'm getting a cutting point, and O2F, here I'm getting a cutting point. I think 9 varun nenikiren. 9 cutting points. Next one is the last one. The last one is the 5th cutting point. You can project up to O2E. So then you can mark this one as 5, and this one as 6, and this one as 7, and this one as 8, and the last one as 9. So totally 9 cutting points. Okay, so இந்த இடத்துல வந்து பார்த்தீங்கன்னா என்ன இருக்குன்னா B dash of H dashங்கிற ஒரு லைன் போகுது, அந்த லைன்லயும் டச் ஆயிருக்கு. ஸோ B dash H dashக்கு முன்னாடியே நமக்கு என்ன ஆகுதுன்னா ஃபர்ஸ்ட் பாயிண்ட் வந்துடுது. ஸோ ஹியர் ஐ எம் ஹேவிங் 2 cutting points, அகைன் 2 cutting points. பாட்டம் பேஸ்ல 2 cutting points, அண்ட் டாப்ல B2Hல ஒரு cutting point, இங்க 2 cutting point, இங்க 2, இங்க 1. ஸோ டோட்டலி 9 cutting points. Okay, so after creating these 9 cutting points, you can join all these 9. That means 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, and 8 to finally 9. Okay, so after doing that, you can connect all these cutting points with an arc. And also you have to highlight, that means you have to create a section line, that means hatching line. Okay, so you can create sectioning on this inner surface. So we can call this as sectional top view. Then similar to that, you can create your parallel imaginary reference line. Then you can project all your 9 points up to this. Okay, so if you are doing that, you will be getting all the 9 cutting points similar to this. So distance எப்படி இருக்கணும்? From this reference line towards this cutting points, அந்த distance measure பண்றீங்க, இந்த படத்துல பாயிண்ட் வைக்கிறீங்க, ஆர்க் அடிக்கிறீங்க. If you're joining or if you're creating a arc with your free hand, you will be getting a shape of parabola. Okay, if you measure a distance of 11291, you will be getting a distance of 35 mm. That is what our condition. It should have a distance of 35 mm. In the line 35 na compulsory, in the line 35. This is what our true shape. The shape is a parabola. Okay. Any doubts? நான் சொன்னது வந்து பாத்தீங்கன்னா கோன்ல இவ்வளவு கண்டிஷன் சொல்லிட்டேன். Similar to that, each and every solid is having the same kind of conditions. Procedure for creating the sectional diagram and the true shape is similar. There is no changes in the procedure. Only the sectional plane condition is different for each and every solids. அது மட்டும் நீ கரெக்டா பண்ணிட்டீங்கன்னா similar rest of procedure is same. ஓகே, அதனால நீ கான்செப்ட் புரிஞ்சிச்சுன்னா நீ இதை வேற எதை பத்தி கவலைப்படணும்னு அவசியம் இல்லை. எந்த ப்ராப்ளமா இருந்தாலும் போடலாம். ஏதாவது டவுட்ஸ் இருக்கா யாருக்காவது? ஓகேப்பா. So you can leave this meet. You can join sharply before 11:15. ஸோ ஷார்ப்பாக ஜாயின் பண்ணிடுங்க. 11:15க்கு ஷார்ப்பாக அட்டன்ஸ் எடுத்துருங்க. ஒரு 5 minutes முன்னாடி ஜாயின் பண்ணாலும் பரவாயில்ல. 11:15க்கு நான் அட்டன்ஸ் எடுத்து ஸ்டார்ட் பண்ணிடுங்க. ஓகே, தேங்க்யூ.
Thank you, sir.